Two teams, same model. One built an agent you can trust in production, the other built a coin flip. The difference was never the model. It was the system built around it. The harness. Agent equals model plus harness. That equation is what this video breaks down. Do not confuse these three layers. Layer 1, the model. The reasoning engine. Give it a prompt, it gives you text. Outside its training data, it starts guessing. That guessing is hallucination. Layer 2, the runtime. The loop. Observe, decide, call a tool, act, repeat. This is what Codex and Claude Code turn into a product. Layer 3, the harness. Everything wrapped around that runtime so the loop stays reliable. This is our whole focus today. The first question is never, is the model smart enough? It is, what are we giving it to work with? Here's the map. 11 primitives. Each one exists because the one before it hit a wall. Instructions cannot see your files, so you need context delivery. Delivery floods the context window, so you need context management. The model needs to act, not just talk, so you need a tool interface. Tools need somewhere safe to run, so you need an execution environment. Work needs to survive between turns, durable state. Multiple steps need coordinating orchestration. Some jobs need a specialist, sub-agents. Repeated procedures get named, skills, and at the top, proof and traceability, verification and observability. Primitives 1 through 3 are about what the model knows. Instruction shapes behavior. Who it is, the rules, the tone, the coding style. Files like agents.md or claude.md move repeated guidance into the environment instead of retyping it every time. But instructions are passive. They can say, follow convention. They cannot discover it. Context delivery hands the model the material, the relevant file, the failing test, the stack trace. A bug fix with a source file attached is a different animal than one without. But dumping everything in is not engineering. Long transcripts and huge logs overflow the window. Context management decides what enters the model right now. Retrieval, re-ranking, summaries, compaction. The attention inside that window is not free. And wrong context is worse than missing context. It is a plausible distraction. Primitives 4 and 5 are about what the model can do. Tool interface turns talking into acting. A structured call with a name, a description, a schema. The model decides which tool to call with which arguments. Now it can request action, not just describe it, but where does that command run? With what access? And can you trust what comes back? Execution environment answers that. File system scope, network policy, credentials, sandboxing, containers, dev containers, isolated work trees. The win here is simple. You do not ask the model nicely to avoid your secrets. You build the box so it cannot reach them at all. Primitives 6 and 7 are about continuity. Durable state is the workbench that survives the turn. Plan files, checkpoints, task state, memory. Progress becomes inspectable outside the model's current attention. So a crash does not erase the work, but state only preserves work. It does not decide what to retry or when to call in a human. Orchestration is how the work moves. Lifecycle hooks, retries, approval gates, human handoffs, step ordering. This is where the agent stops looking like a chat window and starts looking like a runtime. But one agent still has one attention stream. Branching into real parallel work needs something more. Primitives 8 and 9 are about scaling the work. Sub-agents split the job into specialists. One explores the code base, one reviews the diff, one verifies sources. Narrower job, narrower context, narrower tools. But if every sub-agent invents its own process, you get parallel inconsistency. Skills fix that. Reusable procedures, encoded know-how loaded at the right time. When to use it, what steps, in what order, which tools to prefer. Repeated expertise becomes a named, callable capability. But a skill makes work repeatable. It does not prove the work actually succeeded. Primitives 10 and 11 are the trust layer, and this is where most teams are thinnest. Verification, the agent says, I am done. The harness asks, show me. Tests, builds, type checks, lint, browser screenshots, evals. You do not trust the final sentence because it sounds confident. Verification tells you what passed. It does not tell you why something failed. Observability is the recorder for the run, traces, tool call timelines, cost, latency, every prompt and tool version, every approval event. The bug is rarely in the final message. It is 3 steps earlier. You cannot improve what you cannot inspect. This is what turns the agent messed up into a debuggable system. Here is the payoff. Observability feeds the evolution of the harness itself. It is the agent version of a postmortem. Do not just explain the incident. Change the system so that class of failure has a harder time coming back. A repeated context miss becomes a retrieval rule. A bad tool result becomes a stricter schema. A dangerous command becomes a permission gate. A missed edge case becomes a new test. A recurring correction becomes a memory. A repeated workflow becomes a skill. The point was never a perfect run once. It is making the next run start from a better place. With this layer, the harness compounds. Without it, every session is the same lesson in a new wrapper. So here's the practical test. Stop asking only, was the model good enough? Walk the harness instead. Was the instruction missing? Was the context wrong, or did memory go stale? Was the tool schema vague? Did the command run in the wrong environment? Did the work need durable state or orchestration? Should it have been delegated? Was a skill missing? Was there no verification or no trace to look inside? And did we learn nothing from the last failure? That is the shift from clever agents to dependable systems. The model still matters, but reliability gets built into the system around it. Agent equals model plus harness. 11 primitives, each one earning its place. The next time an agent fails on you, do not just blame the model. Ask which layer ran out of road. Mattei Systems helps teams build that harness properly, from instruction to observability. If you are building agents for real, let's talk. MatteiSystems.com